Swayam Prabha. Digital India. Educated India.
In this lesson, we will consider another variant of the substitution theorem, where we substitute the element with a voltage source instead of a current source. Okay. Let me again consider a circuit with an element E connected to it. It has a voltage V across it and a current I through it. Okay. Now, let me make the following construction. First of all, I will consider a series combination of two voltage sources and connected oppositely. See, if you look at the polarities, this has the positive sign on the left side and this on the right side, and both have a value of V. Okay. Now, this is equivalent to a single voltage source whose value is the sum of the individual values, and if you look at it with the polarity, this way I have V, and in the same polarity I have minus V because of this source. So, the whole thing is equivalent to a 0 volt voltage source. Okay. And a 0 volt voltage source is nothing but a short circuit or a wire. I can place this more fancy short circuit in any wire I choose to in the circuit without altering it, because I have not really changed anything at all. Okay. It is only that instead of thinking of it as a wire or a short circuit, I am thinking of it as a series combination of two voltages of equal and opposite values. Okay. So, this will be exactly equivalent to, let me replace this wire by my fancy short circuit. Remember, between here and there, it is just equivalent to a wire. So, this whole circuit is exactly equivalent to what we had earlier, with this element E carrying a current I and having a voltage V across it. Now, this itself is V and this is also V with the other polarity. Okay. So, this way it is V and that way it is also V. Okay. Now, let us consider the voltages at this node and that node. Now, we can take any reference we want, but just for simplicity, let me take this node itself as the reference. I could take anything else I want, it does not matter at all. Now, with respect to this reference, the voltage at this node, I will show that in red, the voltage here is V. At this node with respect to the reference, it is V. Okay. That is the voltage, because from here to there you have a potential rise of V, and from there to there you have a potential fall of V. Okay. So, the voltage here with respect to the reference node equals a rise of V minus V due to the fall equals 0. Okay. So, these two nodes highlighted in pink have 0. The reference by definition has 0 voltage, and this has the same voltage as this reference, which is also 0. Now, what does this mean? This means that I had mentioned this earlier and used it earlier also. If I have two nodes in the circuit with exactly the same voltage, I can connect the two together without altering anything else in the circuit. Okay. So, I can do this. Okay. So, I can connect those two together. Now, let me redraw this new configuration. I have the rest of the circuit. I have the first voltage source, which I will choose to draw this way. Okay, because I have short circuited it. If I number these as terminals 1 and 2, I have short circuited this node to node number 2. okay, this terminal 2 of the circuit. So, I have this 1 and 2, and then from this point on I have also a voltage source of value V and the element E. Okay. Now, it must be pretty clear that the current through this is 0. That is because I also know that originally I had a current I flowing through the element in this direction and also in that direction through the voltage source V. Now, this is not something new I found. This is exactly the same as what was in here. Okay. I had a current I flowing in that direction. With the redrawn circuit, this voltage source is drawn with the negative terminal being at the bottom, and this element is drawn as it is. So, I have the current flowing that way. Okay. Now, if you complete this, this current I flows that way, and if you find the current in this particular wire, that I will be 0, because this I goes into that and nothing comes into that wire. Okay. Now, in general, if you have these two isolated circuits which are connected only by a single wire, by Kirchhoff's law, the current has to be 0. Okay. Another way to think about it is apply Kirchhoff's current law into this whole big green circuit. There are no other wires going into this circuit, and the sum of all currents going in has to be 0. So, the current in this wire, which is the only wire going into the circuit, has to be 0. Now, because the current in this is 0, I can also cut it off and remove that from my circuit. So, I will be left with okay. Remember, I started off with the element E connected to the circuit like this, okay, and that is the same as this, because the series combination of voltage sources is a short circuit, and that is the same as this one. This is simply a redrawn version of that circuit, and this is the same as that. So, the statement of this idea is another variant of the substitution theorem. If I have a circuit with an element E which has a voltage V across it, the element E can be substituted by a voltage source of value V. Okay. And if you make this change, no branch voltage or current in the circuit will change. In other words, the circuit will not be changed at all. Okay. If an element E in a circuit has a voltage V across it, then the element E can be replaced by a voltage source of value V, and of course, this is without altering any voltage or current in the circuit. Okay. So, this is another variant of substitution theorem, where you substitute the element with a voltage source instead of a current source. Now, let me show another quick illustration. I will take the same circuit I had taken with the earlier illustration, 1 kilo ohm and 4 kilo ohm. across a 5 volt source, and we know that a current of 1 milliamp flows this way. Now, let me choose to substitute this with a voltage source. Now, the voltage across the 4 kilo ohm resistor is 4 volts. So, what I will do is take the same circuit, keep all the other components intact. This is 5 volt, but here instead of the 4 kilo ohm resistor, I will connect a 4 volt source. Okay. Now, we have to verify if the currents and voltages in the circuit have changed. Okay. Clearly, you see that across the resistor we have 1 volt drop, that is 5 volts minus 4 volts. So, the current through this is 1 milliamp. Okay. So, just like before, a 1 milliamp current is flowing in the clockwise direction through this loop. Now, the voltage across this is obviously 4 volts, and across here it is 5 volts. So, comparing element by element and comparing this voltage source to this resistor, we see that no branch voltage or current has changed in the circuit. Okay. Like the other variant with the current source, this is useful for proving theorems, and sometimes in actual circuit synthesis, under some conditions, if the voltage source can be replaced by a resistor also. Okay.